Today's video, we're going to be looking at transformations. Now we're going to take a look at transformations visually and also see what happens to the coordinates of the points of any geometric figure. So when you think of transformations, think of like transform, it changes into something. There's different types of transformations. There's translations, which means it is sliding from left to right, up, down. So you go left, right, you can go up, down. So basically you're sliding your figure in different directions. All right, let's take a look at what a translation looks like visually. So in this figure, this red figure, I'm going to translate this right 5 units and then up 2 units and see what happens to that red figure. So let's look at that. So it goes to the right 5 and up 2. So each point goes right and then up, right and up, right and up. Okay. Now, what does a translation look like when you perform it on a point? So, if I had the point -3, 2, and I wanted to translate that right 4 down 6. What you would have to do is take the x value, and since you're going right, it's going in the positive direction, you have to add 4 to it, and take the y value and move it down 6. So you would subtract 6 from the y value. So -3 plus 4 would be 1, and 2 minus 6 would be -4. So that's what happens when you get from the point -3, 2 to 1, -4. That's what happens when it translates right 4 down 6. Now, if I said left and up, instead of adding 4, I would be subtracting 4 and then adding 6. So it would be, not this point, it would be -3 minus 4, which is -7, 2 plus 6, which is 8. All right. So left and right. Left means you subtract from x. Right means you add to x. Down means you subtract from y. Up means you add to y. All right. So that's what a translation looks like. Another type of transformations we're going to talk about are reflections. And we took a look at this year at reflections over the x-axis and over the y-axis. When you reflect something, basically what you're doing is flipping it. So let's take a look back at our other figure and see what that looks like visually. So we have our figure, and we're going to first, let's reflect it over the y-axis, see what happens there. So basically it flips over the y-axis to the other side. Notice A, okay, A is 2 spots to the left. A prime is going to, or actually 3 spots to the left. A prime is going to be 3 spots to the right. E is 2 to the left. E prime is 2 to the right. So it's basically you're just changing the y values. All right. So if I had the point, um, if I had the point -3, 5, and I wanted to flip it over the y-axis, it would become, you're just changing the x values. It would become +3, +5. So when it flips over the y-axis, you just change the sign of x. Now let's take a look at what happens when you reflect it over the x-axis. So if I take my figure and reflect it over the x-axis, it flips vertically. So A goes down 2, A prime goes up 2. All right, so flipping it over the x-axis. So when I reflect something over the x-axis, that means you're going to change the sign of y. So my original point, -3, 5, is going to become -3, -5. So it reflects over the y-axis, you change the sign of x. If it reflects over the x-axis, you change the sign of y. All right, so we talk about reflections. Rotations. So when you rotate something, you could rotate it 180 degrees over the origin. You could do 90 degrees clockwise, or you could do 90 degrees counterclockwise, which is the same thing as a 270 degree. It's also known as a 270 degree clockwise rotation. Same goes with a 90 clockwise. It's a 270 degrees counterclockwise. So we'll take a look back at our figure, and we're going to rotate it 180 degrees. And let's see what that does. So it takes it and rotates it 180 degrees about the origin. So it changes into a totally different quadrant. So it starts off in quadrant 3, then goes to quadrant 4. So in order to rotate a point 180 degrees, let's pick the point 5, -3. You have to change the sign of x and y. So that 5, -3 would become -5, +3. So you change the sign of x and y when you want to rotate something 180 degrees. Okay, if you want to rotate something 90, let's take a look. If you want to rotate it 90 degrees, let's if you rotate something 90 degrees, it goes into the next quadrant over counterclockwise. So it rotates not as much as the 180 degrees, but pretty much like half half the distance about the origin. So when you want to rotate a point 90 degrees clockwise, in that case, it was counterclockwise. I'm going to use the point. I'm going to use the point 5, -4. So 5, -4 is located in the third quadrant. So if I want to rotate it counterclockwise 90 degrees, it would end up in the first quadrant. Okay. What you do with the numbers is you switch the numbers, so then it becomes 4, 5, and then you use the sign scheme of the quadrant is going into. So the sign scheme of this one is positive, positive. So it's +4, +5 would be the coordinate of your rotated point 90 degrees counterclockwise. Now, if I said clockwise, okay, it would end up in the third quadrant. So you would still switch the numbers. So it would be 4, 5, but the sign scheme of the third quadrant is negative, negative. So it'd be -4, -5. So let's refresh our memories on the sign scheme of each quadrant. We have positive, positive. We have negative, positive. We have negative, negative in the third quadrant. And the fourth quadrant is positive, negative. So this is quadrant 1, 2, 3, 4. So those are the sign schemes. Let's take a look at another example. Let's do rotate it 90 degrees clockwise, and we'll use the point -6, 2. So -6, 2 is located in my second quadrant. If I'm going 90 degrees clockwise, well, first I switch the numbers. Right? Switch the numbers, so you get 2, 6. Now the sign scheme, so it goes 90 degrees clockwise, it's going to end up in the third quadrant, which is a negative, negative sign scheme. So it's going to be -2, -6. It's going to be your point rotated 90 degrees around the origin. If I said 270 degrees clockwise, that would also mean the same thing as 90 degrees counterclockwise. So it would actually end up in this quadrant, which would be positive, positive. So it would be +2, +6. So 270 degrees clockwise is the same thing as 90 degrees counterclockwise. And the sign scheme of the first quadrant is positive, positive, obviously. All right, so those are 90-degree rotations, 270-degree rotations, clockwise, counterclockwise, and 180. 180 doesn't matter what direction you go, clockwise or counter. It'll end up in the same spot. The last type of transformation is going to be called a dilation. So I am going to dilate a figure. All right, let's dilate this figure right here, the red figure, by 1/2 and see what happens. See what happens to my figure. It actually just decreases in size and gets smaller to the origin. All right, so if I try that again, it decreases in size and gets smaller to the origin. All right, do it one more time. So what we have to do with each of those points would be to multiply each of them by the scale factor. So that's the important part of dilations. So if I want to dilate 10, 15, okay, you have to multiply and say I want to dilate it by a scale factor of 1/2. So what you have to do is multiply x and y by the scale factor. So you would multiply 10 times 1/2 and 15 times 1/2, and that would get you your point after it's dilated be 5, and half of 15 is 7.5. All right, so you do get an ugly decimal with that. Now, if I wanted to do the instead of making it smaller, make it bigger. Let's look at an example where we can make it bigger. This one right here. We're going to take a look at the red figure and dilate it by 2 and see what happens. Boom, gets nice and big right there. So what you would have to do is multiply each of those coordinates from the red figure, multiply them by 2 to get your transformed figure. So an example would be, let's do the point -3, 8, and my scale factor is going to be 3. So when I dilate this, again, you multiply each of these numbers, this number and this number, by 3. So -3 times 3 is -9. 8 times 3 is 24. So that's what my point is going to look like dilated. All right, so to recap, we talked about transformations or translations. That means you add or subtract a number from x, and you add and subtract a number from y, or subtract a number from y, depending if you're going left, right, up, down. So in this case, adding to x would be going right, subtracting would be going left, adding to y would be going up, subtracting from y would be going down. All right, so we have a translation, okay, a reflection, right? When you reflect something, you change the sign of over the x-axis. Means that you change the sign of y, and for the y-axis, you change the sign of x. A rotation of 180 degrees. Rotate 180 degrees means you change the sign of x and y. And when you rotate it 90 degrees or 270, you switch x and y, the numbers and the coordinates, and then give the appropriate sign scheme. Sign scheme. All right. The last one we talked about was dilation. So dilation, you multiply x and y by your scale factor. Okay, a fraction of the scale factor, a number between 0 and 1 is going to make it smaller. Anything greater than 1 is going to make the object bigger. All right, so that's it for today's video. When you work on these questions in class, just make sure you're following these rules with the transformations. And if you have questions, please let me know. Thank you for watching.